All right, well, let's kick off. Happy Thursday, happy 31st of October as well. As I said, I'm Nikki Kinlock. I'm the CEO of Cure Cancer. And thank you for joining us again today for today's Lunch and Learn session, which is with Dr. Anthony Chen, as we mark Lung Cancer Awareness Month in November. This is particularly meaningful, as you might understand, to Dr. Chen, and he's going to share his innovative research with us. Dr. Chen leads a research group at the University of Queensland at the Frazer Institute, where he's working to better understand and treat lung cancer. His work focuses on finding ways to help our immune system fight cancer more effectively. Think of it a little like training our body's natural defenses to better recognize and attack those cancer cells. With support from his Cure Cancer grant, Dr. Chen is developing new treatments that combine specially designed antibodies with existing immunotherapy. By strengthening how our immune cells fight cancer, these treatments could slow cancer growth and potentially lead to better outcomes for patients. His team is also working on tests to help doctors match the right treatment path to each patient, which could mean better results with fewer side effects for those going through treatment. Our fundraising campaign to support this kind of vital research continues, and if you'd like to contribute, you'll find the donation link in the chat. For those watching on YouTube, you can also find the link in the video description or scan the QR code on your screen. We're very excited to hear more about today's session from Dr. Chen. So please share any questions you may have in the chat, and I'll weave those into our discussion as we move forward. And finally, this session will run for about 45 minutes, so we'll finish just before 1:15. So without further ado, I'd like to welcome Dr. Anthony Chen. Anthony, welcome today.
Thank you so much, Nikki. Hello, everyone.
So we're very excited to talk to you today. You and your team are doing some incredible work, particularly on lung cancer, which is sadly one of the biggest killers still in the world. But before we talk about your critical research, we'd like to learn a bit more about you. Some may not be familiar with you on the call. So can you tell us a bit about you and your background and before you got into research?
Yes, thank you so much for this opportunity. So I would like to introduce how I actually got to this research career. I grew up in a small town in southeastern China. It's a very small town. So to help with the visualization, I actually sneaking a picture to help explain it. So it's here, it's a very small town. And here we have a bicycle. So I think many people in China, especially the last generation, will recognize it. It was a very common model back in 90s and early 2000s where I grew up. Because by that time, car is not very very rare in most families. So my father used to transport me everywhere, just on the back seat of that bicycle. And on those rides, we often talk about, all kinds of scientific questions that I was curious about, like from the universe to the animals to the plants. To be honest, it wasn't really scientific because none of us have the, knowledge. It's more like a way of imagination of what science could be. But then one day, my father just said to me that, when you become a real scientist, you will have to tell people that your scientific mind was born on the backseat of your father's bicycle. So I think what I try to say is that being a researcher or a scientist has been the only career I've been thinking of since my childhood. And then I was really fortunate afterwards. I got to a pretty good university in China, known for its life science program. And I found myself interested in immunology specifically. And later, I was even more fortunate to have the opportunity to come to Australia to pursue my PhD in immunology. So that's how I came to here today.
Lovely. So we talk about immunology, and it's quite a journey from a little country town in China to Brisbane. But do you want to explain to people, because we'll be referring it throughout this conversation, what is immunology and also immunotherapy as well?
Yeah. So yeah, thank you for that question. So I think immunology, to explain it in a simpler way, is the mechanism, a defense system in our body that help to protect us from the pathogens invaded into our body from the environment. And also it helps to clean the internal pathogens such as tumor cells. But it's just in the ideal situation. But in pathological context, our immune system can get dysregulated or could be suppressed. That's why it failed to clean, the pathogens. So that's why immunotherapy is required to harness the power of our immune system and to fight against those pathogens, including tumors.
So if I get this right, and correct me if I'm wrong, but my understanding is that, we always have toxins in our body. We are always developing cancer cells, but our body deals with them every day as part of the normal process. Is that right?
Yes.
Yeah. So, but in some cases, then this doesn't work. And the body doesn't deal with them, so that we need to do other treatments to be able to help assist the body with dealing with the cancer cells.
Yes. Yeah, I think that's the ultimate goal, if we can find the right way to harness our immune system and to help improve the anti-tumor immunity.
And it's quite remarkable. I mean, we've talked about this before with several other researchers, typical treatment in the past, and we'll talk about lung cancer specifically in the future, but typical treatment in the past has been invariably chemotherapy. And chemotherapy, whilst it does work, it is very strong and can often be deadly and, of course, very toxic to the body. So having another option like immunotherapy, either by itself or in a combination with chemotherapy, seems to be a very significant step forward in the research world.
Yeah, definitely. And also, I would like to emphasize that by immunotherapy, we talk about the immune checkpoint inhibitors, because that has been a landmark discoveries or applications in the past decades in the cancer therapies. So whether as a single agent or in combination with the chemotherapy, there has been demonstrated to be able to significantly benefit the survival of many patients.
Yeah, absolutely. Well, let's take a step back then. So you came over here to do your PhD, and you were looking at immunotherapy. How do you make that transition? What interested you in regards to lung cancer?
Yes, so thank you for the great question. I think to answer this, I would like to divide into two parts. Please bear with me. Hopefully it's not too long, but please feel free to cut me off. First of all, why we choose to do the cancer research? I think because it's the greatest challenges in human health, of course. And I think not just me, for most people working in immunology, there's like innate natural motivation to apply the knowledge to help understand the cancer biology better. And also personally, I think this drive also comes from my family and the family friends who unfortunately have been diagnosed with the cancer. So that's when I became even more aware that this problem is not, that far away from our life. So that drives me want to, hopefully contribute in some way, no matter how small it is, to progress in this field. Then we come to lung cancer, why we choose to study on lung cancer. So as an immunologist, my research focused on a specific type of immune cells, which is called T cells. Let's not try to sneak in too much jargon today. So it's the first one. So the T cells, and then there's specific category of T cells called T helper cells, because it provide all these critical helper signals to other immune cells, including those cells working the anti-tumor immunity. And then recent studies, particularly one with the preclinical model of lung cancer, it just shows that this specific type of T helper cells, it plays a key role in achieving better outcome in lung cancer patients. And more importantly, lung cancer, as you kindly introduced earlier, is a very deadly kind of cancers. And in most of patients, their response rate to the current immune therapies is quite low. So it definitely requires more research on its pathological and immunological mechanisms. So that's why we choose lung cancer as the focus at this moment, to see how we might be able to harness our knowledge and to inform future immunotherapy development. I hope it's not too exhausting answer for this question.
No, not at all. No, it makes a lot of sense. I mean, I was looking at the stats around lung cancer in Australia in 2023, and obviously they take time to release the stats, but they're thinking that last year there was over 15,000 diagnoses of new cases of lung cancer in Australia, and it is the 5th most common diagnosed cancer in Australia, with the lowest survival rate of all of those cancer types. So it is obviously a significant problem. One of the questions I get asked frequently, and this may not be one that you can answer, but maybe allude to, that, given the global impact that lung cancer is having on people, why do you think it's so far behind in research and progress, and the survival rates are still sadly so low compared to other cancer types?
Yeah, thank you for this question. I think it's a very important question, and I'm afraid that based on my expertise, I cannot provide a perfect answer. But in my understanding, from perspective of immunologist, the cancer biology is a very, very sophisticated field of study. And to be honest, our understanding on the biological mechanisms of cancer onset and progression, in particular how it's interplay with the immune system, hasn't been really, I think it's still far away to say that it's well known. So there's still so many mechanisms to be reviewed by the active study in the field. And also, I think our previous studies in the field has been, always limited by advancement of technologies. So with the advancement of new techniques, I think also bring the new opportunities for us to deepen understanding on both the biological mechanisms and also immunological mechanisms of lung cancer.
Yeah, I think it's a very valid point. We've heard that a lot from researchers, particularly those that have been studying and doing research for a long period of time, 20, 30 years. They say that sometimes they had these ideas 20 years ago, but couldn't actually make them happen because the technology wasn't there to make them happen. Whereas now technology has caught up with the ideas, which is why we're seeing quite a great advancement in research and the impact on everyday patients in 2024.
Yes, yes. And also, even though there's still many big questions to be addressed in different fields of cancer, especially lung cancer, but we can see that just in the past decades, with the improvement or with the advanced understanding from different fields of cancer biology, I think the survival rate of the patient has already been significantly improved. So I think that's also kind of encouraging. We start to have more and more options or weapons to target different cancers. Yeah.
Yeah, absolutely. So just before we dig in, just a reminder, if any of you do have questions, please drop them in the chat box. You can put them in the general conversation, or you can direct them to me as well, and I'll talk to Anthony about those as they come up as well. So let's dig into the conversation about specifically, and this is where we might get a bit more scientific, but what you and your team are looking at and why you're looking at it. So first of all, we've talked now a couple of times about immune checkpoint inhibitors. For those that don't know what that means, could you explain that in more lay terms for us, please?
Yes, thank you for that question again. So for this purpose, I think my language will be too plain. So please allow me to sneak in another pictures to help hopefully visualize the point a little bit better. So we know that in cancer, the immune cells can easily, oh, sorry, somehow it's a mirror, sorry. Yeah, the immune cells can be easily exhausted, just like human get tired. That's because they have been constantly exposed to overwhelming amounts of antigens, but they are also keep receiving inhibitory signals through the cell surface proteins called immune checkpoints. It's like the brakes of our immune system. So their physiological role is to prevent the overactivation of the immune response. Mm-hmm. For example, when we get the virus infection, we don't want the immune response to keep going forever. That will initiate damage to our own bodies. So there are these physiological immune brakes, such as the famous molecules such as PD-1 and CTLA-4. But then in the context of cancers, because our immune cells get these inhibitory signals from these immune checkpoint proteins, that somehow suppress the immune response, which makes it under a threshold to be able to effectively clean the tumors. So that's why immune checkpoint inhibitors is a very cutting-edge discoveries, because they can bind to those immune checkpoint proteins and block those inhibitory signals directly. So they can help immune cells to stay active in their fight against the cancers, and that's often lead to significant benefits in extending patient survival. Now,
so let me just repeat that, just so to make sure that I understand this. So essentially, the physiology of our bodies are that we are stopping an overreaction of cleansing of whatever is bad in our bodies, because otherwise it could keep going on. So that naturally happens. However, because of that, it's then also stopping the cleansing of the cancers or the tumor cells too. So that the inhibitors will combine with the protein and then enable that process to continue to happen rather than stopping. Is that correct?
Yeah. Exactly. That's exactly right. So it's like a mechanism, but being hijacked by the tumor cells.
Yeah.
So, but then upon saying that, why we still need to do our research, since we already have the immune checkpoint inhibitors. But that's because immune checkpoint inhibitors is great, but it's not perfect. It's far from being perfect, because in many cases, in many types of cancer, especially lung cancers, the patient's response rate, as we mentioned earlier, to the current immune checkpoint inhibitors remain quite low, often below 20%. So we definitely need additional strategies to improve patients' response to the immune checkpoint inhibitors. So that leads to my research topic, because the question essentially is what we can use to combine immune checkpoint inhibitors with. Yeah. So
that makes sense. I've just had a question coming, which is quite interesting. So
yeah.
can you artificially increase the level of inhibitors in your body?
Oh, yeah, that's actually a very great thought. And I think there's definitely someone is actively working on that.
Mm.
So not necessarily increase the expression level of the inhibitors per se, but there are technologies try to help with maintain those inhibitors on the surface of cells. Because in the physiological context, once they get engaged with its ligands, they get internalized inside of cells. Anyway, so their level on the cell surface get decreased. That's also part of the reason why the immune checkpoint inhibitors doesn't work very well. So there are innovations to help maintain those inhibitors on the cell surface to help with that. So I think this is a very, very important questions in the field. And I think the researchers across, all the different countries, they have their innovative ideas to help contribute to solve these questions. I don't think any of these will be, the perfect answer that universally applied to all different cases. But the more options we have, the more promise, we can eventually reduce the problem as much as possible.
So question then, if you're a patient, how do you know, or how does the clinician know that your inhibitors aren't working, or everything is slowing down and it's not killing the cancer cell? What process happens? Is it a blood test? Is it some other test? How do they know that doesn't work within their body, to enable them to have additional treatment?
Yes. Unfortunately, I'm not oncologist, so I cannot provide a very, very professional answer directly to this. I think in the clinical settings, they definitely have a very standard procedures to help the patient to follow up on the progress of these treatments. And if there is no clear benefits, I think there are also established biomarkers to help people to identify whether they should keep on using this kind of treatment, or they should try to seek alternative therapeutic strategies. Speaking of that, I think as an immunologist, I think they are definitely also immune cells response could be part of those sets of biomarkers. Yeah.
Lovely, thank you. So we've got these inhibitors that we need to get going, get working to start kill the cancer cells. So what's your research in particular, and how does your research relate back to this?
Yeah, thank you. So once again, from my immunological research, our answer lies into the mechanisms mediating the cell-to-cell communications. Once again, it will be a last picture I sneak in today, I promise. So I try to explain why cell-to-cell communication is important in this context. So cell-to-cell communication, just like our human-to-human communications, it happens in two ways. The first one is physical interaction, but that's not too often. The more often one is the remote communications. For the human, we communicate through language, but for the cells, the language they speak is by secreting signaling proteins called cytokine. So I think this will be the last jargon I sneak in today as well. So those cytokines secreted by the cells, they will tell the other cells or the target cells how to do their next step. So each type of cytokine or language spoken by the cells, they deliver unique message to a target cells. And one particular cytokine that we are studying, which is called interleukin 21 or IL-21. It is known to deliver a very unique anti-exhaustion message to the target cells or to the immune cells, and is likely a very important candidate for enhancing immunotherapy efficacy. But then in the clinical trials, IL-21, this cytokine has shown very limited efficacy. But then there's no effect strategies to further enhance its bioactivity. So that has been a bottleneck, I think, to solve this problem. So that leads to my research. So in our lab, we have developed a unique antibody, which is also kind of protein. This antibody protein can bind specifically to IL-21 and will be able to significantly enhance its ability to boost the immune cell response. So we think that this antibody will offer a promising approach to improve our immune response when used alongside with immune checkpoint inhibitors, and potentially leading to better efficacy and the outcome in the patients.
It's interesting. So essentially what you're trying to do is get this protein to then speak to the interleukin 21s to say, here you go, speed up your energy, continue to kill the cancer cells and all the other bad cells as well.
Yes. So we definitely have scientific evidence to back up that. I really appreciate that the review committee of Cure Cancer Foundation recognized that. I feel very honored on that. So that's why we are conducting this further research to better characterize how this antibody works and generate some kind of new immune therapeutic agents. Hopefully can really improve the efficacy of current immune therapeutics in lung cancer.
So essentially what you're trying to do is to make immunotherapy better for lung cancer patients. Yes. Wonderful. Yes, incredible work. So if we were to have a map into the future, and obviously, you know, I'm not going to ask you to commit to anything here, but, you know, we have to do clinical trials and tests and all of that. But the idea then would be that you would test this combination, look at the response it's having, make sure that it is having the right response to the right cells, and then if that proves right, to go to clinical trials. Is that correct?
Yeah, I think the direct clinical promise is definitely we are aiming at.
Yeah.
Yeah, but in realistic, there are still different stages of translation we have to go through. Of course, I think what we are trying to do at this moment is to demonstrate the efficacy of our agents in preclinical studies as much as possible to convince people that it will work in the clinical settings and to speed up and facilitate this translation progress.
A question here I have, which is quite interesting. The protein and linking with the IL-21 or interleukin 21, is that just specific to lung cancer, or could this, if proven to be efficacy to be correct, could you then actually use this to translate this into treatment for other cancer types as well?
Yes, I think that's the ultimate goal. Actually, from the perspective of immunology research, we get the preliminary efficacy of this antibody in other cancer preclinical models. And when we are thinking of what kind of cancers, as I mentioned, can potentially be clinically more related to the function of these antibodies, we think about lung cancer because, like what I said, interleukin 21 and the specific T helper cells produce IL-21 has been demonstrated to be required for lung cancer specifically. But like what we observe in other cancer models, if there's potential, this agent can also benefit other kind of cancer.
Yeah, that would be incredible, absolutely. A question then about collaboration. Do you work with other institutes, either in Australia or overseas? What's that collaboration like in your research?
Okay, yeah. So that's another point. I feel I'm very, very blessed and fortunate because in Brisbane, I can have the opportunity to develop, lots of strong collaborations, both within the institute or with the external collaborators. Because my research program have different facets. So just speaking of the tumor immunology research, I can give example that some aspects of the project, it requires experimental models that are outside my immediate skill set. And to adjust this, I need to collaborate with the the people with the complementary expertise. So that's why I feel I'm very fortunate. I have the opportunity to collaborate with the two outstanding cancer biologists. They are Professor Kuku Khanna and Dr. Ben Rashdi in the Malta Research Institute. So with their expertise, setting up those experiment models become much more smoother and more efficiently. So I also keep getting very important advice from them. So all of these just really help to facilitate the progress of this project. But I think after all, I want to say that I'm still kind of a junior group leader. So so what I want to say is that I'm always very grateful for all my collaborators because they are willing to trust my expertise and my team's expertise. So that's what I want to say, that as return, I always want to ensure that I can contribute as much as possible in those collaborations. And when they need our skills in immunological analysis or specific resources, I will treat them as priority and try to do a job as hard as possible. So I hope eventually it can help like a junior researcher like me to grow the networking and also to grow the collaborations to make it more long-lasting and fruitful in the future.
Oh, that's lovely, thank you. I do have to step in and say that we have funded a lot of researchers at the University of Queensland, and many have had 5 to 10 years tenure in research now, and they speak very highly of you. For you to be a group leader already is incredible. And a couple of them said, I've watched this space, you will go very far. And for those on the call, the work you're doing now is incredible. If we can crack this will really change how we treat lung cancer and then potentially other cancer types as well. So I know you're very modest, but you've done an incredible job so far. So well done there, Anthony.
Thank you so much.
A question for people that may not be aware of, what's your average day look like? What do you go to the lab every day? Is it 9 to 5? Can you talk people through, how you and your team work in your scientific research?
Yes, thank you for that. First of all, I have to admit that I'm a person that's terrible at work-life balance. That's something I really try to improve. One thing I would like to share with everyone is that my wife is expecting in this November.
This November, as in tomorrow.
Hopefully not tomorrow. But then, yeah. So I think this kind of new responsibility require me to definitely manage my time more smartly and spend more time with my family. But a typical day of me is kind of boring. So yeah, so I would say I spend half time in the office just for all those kind of writing tasks and the data analysis, and half of my time I still do experiment by myself in the lab, just to finishing, wrapping up some projects we have before. Since I was like a postdoctoral researcher, so eventually I think I will transit into slowly step out from a lab doing all the experiment by myself. So that's why I feel like I'm very fortunate. I'm in a great team, and all the students are extremely hardworking. So I hope I can set up a better example to them for achieving work-life balance, and or at least we can demonstrate the time that we spend in the research, demonstrate their worth in terms of the outcome, both in academical way and also in terms of benefit, really benefits the people.
Absolutely, absolutely. Thank you. What would you say are your biggest challenges in your role?
Yes. Yeah, first of all, I would like to say that I am very, very fortunate as a researcher. So because the University of Queensland and the Frazer Institute just provide such excellent environments, for research itself and also for mentorship and collaboration. In particular, Frazer Institute, I think that Q Cancer has worked with multiple colleagues of us, and it's a very fantastic place to work. So I would like to say that I cannot ask for more in terms of the support I receive. I'm also in a very great team. I get fantastic mentorship, and all the students work very, very hard. But then the research itself, inevitably, it comes with the major challenges. I think first the challenge comes from the research itself, because we cannot predict what's going to happen in experiments. Lots of time we have a very, very fantastic hypothesis, very novel, but the first or second experiment will prove it's wrong. So through the years, I think I've learned to, and I'm still learning to, how to adapt the research strategies effectively and based on the scientific evidence we have. The reason why we need to do these things very effectively is due to another major challenge in terms of a research career, is because we eventually need to communicate our research findings through the form of publications, which involves very rigorous peer review, of course. And many researchers can relate to this experience that we often get the submission rejected from the targeted journals. It's part of life. So I think staying positive in this kind of pressure is very essential, and it's actually a challenge. So that's because the nature of the research career is very, very competitive. In many cases, people around the world will have very similar ideas as us. So we always have to be try very hard to get this idea published before the others. And finally, I would like to highlight that securing research fundings is critical to sustain our research program. I think I'm still at very early stage, building up my research program. And I was really, really fortunate that in last year, I can receive the support from Q Cancer Foundation, as well as federal government fundings and the UQ internal fundings. But just a year earlier, like many early career researchers, I faced so many rejections in terms of grant applications. So I think for early career researchers, I understand this is a very, very big challenge, how to step out to get the first research grant. And that's why the opportunities like a Q Cancer Foundation is invaluable in offering essential support for the early career researchers to get the things started, to establish and start to grow their own research program.
Yeah, look, absolutely, and that's thanks to the donors on the call as well. I mean, that's why we do what we do, to enable incredible work like yourself and from your team to challenge the status quo and to make a difference, because as we said, lung cancer is the fifth most significant cancer type in Australia, and it is a very big problem that we're yet to solve properly as well. So the money goes directly to people like you who have great ideas and innovations, and we're really excited to see where your research takes you, and hopefully how that in the future can impact patients as they go through treatment as well. We've just got 5 minutes, so if anyone else would like to ask Anthony a question, please just drop that in the chat and I will add that into our conversation. Thank you. So look, we all know research is difficult. You've talked about the many challenges you have. Why do you still do it? What motivates you?
Thank you. So I think especially in the period of stress, what keeps my motivation is that I always remember why I choose this career. That's because we have the questions we want to answer. That sounds so simple, but I think that's our internal motivation, which stems since we are still very young, and that's the things keep, I think, me to fight against lots of negative experience and survive till now. Yeah.
Absolutely. Lovely. And what are your future goals? You're doing this piece of research now, and hopefully you can show the efficacy and then you can move forward with it. Granted, research takes a long time, we know, then it has to go through a whole bunch of approvals, rightly so. But, what are your future goals? What are you looking to do?
Yeah, thank you. I hope it's not too ambitious, but as a scientist, my aim definitely is to establish a world-class research program. Especially, I'm at a very top research platform in the UQ, in the Frazer Institute. So I think this program can encompass both mechanistic discoveries, because that's what we like, and also translational applications. So this is the direction I'm committed to pursuing, and I think I'll try to work as hard as possible to drive the progress.
Lovely. And what do you mean by translational applications when you say that?
We hope that we can innovate more, research outcomes or therapeutic agents has the clinical promise, just as the antibodies we are doing now. So eventually, this research can really bring in the clinical promise to benefit the people at the end.
Lovely. I do have a question here about progress of lung cancer. The research you're doing, particularly in the IL-21, is that relative to any type of lung cancer? Does it matter how far advanced it is? Or is it the same kind of research for the advancement of the whole cancer spectrum, i.e. if it's if it's stage 1, is it different to stage 4, or does this research work equally across more advanced cancer cells?
Thank you. I think that's a question I hope I can provide a better answer. But unfortunately, as I mentioned, first of all, I'm not an oncologist, so those of things hasn't been really investigated clinically. Those things are very at a very early stage in conceptual discoveries. Speaking of the interleukin-21 immunology itself, it's definitely required for demonstrating the preclinical model of lung cancer that is required to maintain the immune cell responses since the very early stage. And I think it's the ultimate goal of our research that eventually the therapy itself can benefit the people across many different stages. But at this moment, I think I'm so sorry that I cannot provide a conclusive or more informative answer that which stage of cancer can particularly benefit. But I think our work will try to work as hard as possible to get more understanding on how the immune cells work through the progression of lung cancer.
Absolutely. Makes sense. Thank you. And finally, before we wrap up, do you have any last words that you'd like to say to our donors and fundraisers listening here today?
Yes, of course. So I've been waiting for this opportunity, actually, to express my gratitude once again. It's a very big honor for me, of course, to be supported by Cure Cancer Foundation, and all the audience. They are the heroes that really enable all this research to happen. And I truly hope that our work can lead to the outcome that can demonstrate the value of the support. That's the thing we are trying to do. Work hard on this every day.
I'm sure it will. It's only a matter of time. So thank you, Dr. Anthony. We really do appreciate your time, and please thank your team as well. It's been fascinating to hear about the important work you're doing through immunotherapy, particularly on lung cancer. To our audience, we will have this recording shared with you in the next week. And if you do have any other questions, please drop us a line at info@curecancer.com.au, and we'll be able to either answer them ourselves or pass them on to Dr. Anthony as well. And we look forward to hearing more as your research progresses as well. So thank you for your time.
Thank you so much, Nikki.
My pleasure. So for everyone else, thank you for your time today. Please join us at the same time on the 14th of November for our next Lunch and Learn, and that's with Dr. Mohammed Saad, where we will be talking about his work on lung cancer as well. So thank you and have a good afternoon.
Thank you. Thank you, everyone.